So the question time is red. Yeah, you have to be careful with the yellow because we are going to finish. Let's start. Hello. So welcome to everyone again for this session. The session 2 of today is on UAV for vegetation monitoring. And we have 8 speeches. The first one is on UAV opportunities for ecology and agriculture. Is from Xurgo Gago. Is the speaker here? Oh, thank you. Is from Balearic Island University, Spain. And this is an invited speech. And we have 12 minutes for your speech and about 3 minutes for questions.
Hi. Good morning, everybody. The first thing I want to say is that thank to the organization and also to Salvatore to invite me for this talk, to share some ideas here. Also to thank the people of the group of Valencia to organize this workshop that I know that is a lot of work. Can I, this one? Yeah. And first I want to introduce myself. I'm not a really remote sensing guy. I'm plant molecular ecophysiology, and for me the drones are the opportunity to take data from the whole plant level for the real crop field. That is something that in physiology is not so easy. I work in the plant biology group, and also I have an important collaboration with the ecogeomorphology group of the University of Balearic Islands in Mallorca. So I have some ideas to share with you, and I will split them in 2 different fields. One is ecology, and another one is agriculture. And the first thing that I want to show you is how we are trying to combine the field of ecogeomorphology and plant ecology. We have a really huge wildfire in Mallorca in the Tramontana range, in the south of Tramontana range in the 2013, and from January 2014 we start to try to monitor this area to see the main problems that we can have after a fire. That is basically erosion, the problem that the recovery of vegetation, and finally the recovery of the landscape. That is really important for Mallorca, because Mallorca, as you probably know, is a really important touristic place of the world. So the landscape has to be beautiful, because if the landscape is not beautiful, tourists will not come. So this is right now there. So it changed a bit. Right now there is a lot of vegetation, mostly shrubs, and mostly one grass that is Ampelodesmus mauritanica. That is a typical species that invade the areas that were burned. What we were doing is using drones, is that we try to get information about potential of erosion and vegetation recovery. So here you can see our microcatchment study, that basically we were applying for a digital elevation model the connectivity index. I'm not an expert on that, but basically the connectivity index gives you an idea about the transfer of energy or transfer of matter between 2 different landscape compartments. And also with the same UAV and with the same camera, we try also to track, to monitor how the vegetation is going. So we can calculate vegetation index, and you can see here the green is that there is a plant, and red that there is no plant. And here I'm sorry to show you that the connectivity index, if you see the red, means that there are higher energy or higher potential of energy in that part of the catchment, and if it's blue, is that energy is reduced. So also with the drones give us the opportunity to have a really important resolution. The resolution can be so precise that we can distinguish even the species. So Okay. Here is Camaerops humilis, that is like a small palm, and here is a grass. We can distinguish because of the shape of the canopy. But also we can distinguish these kind of things here. There are lock barriers that basically is to try to reduce the runoff. And this is what that pines that were burned, they cut it and they put in different places and along the catchment to try to reduce the potential erosion there. So here, I'm not sure if you can see, but all these will be the potential higher flows along the catchment. And then you can see here like obstacles that are basically the lock barriers. Or in Tramontana, they are really important, the terrace, the agricultural terrace that they were abandoned like right now 50 years ago or 60 years ago. And you can see that in the area where the terracing was done, the flows are really, really less important. And as well, we are studying how the recovery of vegetation will affect the runoff, will affect the potential erosion. So here you can see the vegetation in red, and here you can see how this vegetation is affecting the flow. Oh, thank you. How the vegetation is affecting that flows. So finally, we are working with the Environmental Council in Mallorca, and we give them the information about how it works, their different techniques to try to stop the runoff, to reduce the soil losses, and we make these maps. In green, there are the plants. In red, they are the most probably potential areas with higher flow, and also you can see here how the terrace and the lock barriers are affecting all of them. Another example of this is that we also work in agricultural field. This is a cereal field that is mostly flat if you compare with the previous area, and that was absolutely plow. And here is the connectivity index in that area. And here you can see a digital elevation model of difference. So how makes an agreement with the potential flow with the final erosion, that how many soil losses will you lose if an important precipitation event or something that a really important runoff will happen there. So I will also speak about agriculture. Right now in agriculture, we participate in different projects, same European projects. Oh. How much?
3 minutes.
European projects. And you can see here a really huge tomato field. And here in this kind of projects, we try to know who is best for. So we have different cultivars, different accessions of tomato, and we impose their optimum conditions and stress conditions. So we use the drones to characterize the plants, and here is the field, and here we can say the optimum conditions and the stress conditions, and the resolution that we have, that we can distinguish the plants and the foliar area of the plants. And also the NDVI map, and you can see that the optimum conditions is around here. You can see that it's greener, and here there is not so green. That means the green that is a more vigorous plant, more growth there. And this, then we collect all the tomatoes from the different species, from the different plants per plant. We characterize them. And can you take the play there? And this is when they have to make the characterization. My students and the rest of the colleagues getting crazy in our field lab because it's a lot of samples over there. And also what I just want to end is that new opportunities for the UAVs. So the problem right now is that maybe the private companies or the research, we have the potential and the power to run the UAVs. We have all the image aerial processing that we must do with all the calibrations, the calibration of the sensors and all that stuff. But for the normal people, this is not so easy. And this technology, I think, have to be useful for people, for the public domain. So this kind of small drones can be really useful for different applications. Can you make the play? This is an experiment that we did inside a greenhouse in the Max Planck Institute. This is an experiment for phenotyping the plants. So we use that small drone that is from Parrot. We put there 2 years ago, I think, a HD camera, and we're using the drone to fly inside the greenhouse. So this is like a phenotyping platform. The phenotyping platforms are really highly costly because you have to put a lot of cameras in different trails along the greenhouse, and they are fixed. But with the drones, maybe can give you an opportunity, an easy opportunity, maybe low-cost opportunity to characterize the growth of your plants in a simple manner. So there is the drone flying over the Arabidopsis plants. Arabidopsis plant is the model, it's a model plant in plant physiology. All the genome is sequenced right now, so it's a really important thing. So you can see now the image from the drone itself. And here that typical ortho model that we can take out to calculate the growth of the plant. And this idea also can be really important as a simple trait for more public domain, is that if you characterize the growth of the plant, so in a culture, in a crop that is highly, highly well structured, like could be the vines, and here I can show you an experimental setup, that's if we apply different irrigation treatments, then we can see how the water affects to the growth of the plant. And we can calculate that growth in a conventional manner, that is a person that have to count all the stems of the vine, measure the stem and count the leaves, so it's highly time consuming, or you can calculate by the drone. And then you can get this kind of relationship. Why can be important for a farmer the foliar area? Because the foliar area, how much bigger is the plant, usually is related how much production you can have. So this is the relation right now in the productivity per plant and the area that is estimated by the drone. And also, it's important that that area, that foliar area, is also related with the commercial size, because not all the crops are good to sell. So there are some commercial size that are the important ones. The money is there. And also the foliar area can be related with that. Also with micro drones, with small drones, you can fly in a different way than previously. You can fly really close to the plants, so close that you can distinguish the number of crops per plant and the size of the crops. So we check the number of crops per plant, in manually counted, with the number of crops that we can detect by the drone. I think this is a really interesting application, because this way, in a simple manner, the farmers can have a direct information about the productivity. So that means about the final money. And I think I would like to share with all of you that the micro drones can be a really important opportunity from right now on, because they are more simple than the previous drones. Obviously, they have lower safety risks. They have high potential for technology improvements. And right now, the interface, how to exchange data with them, thanks to the smartphones, are more friendly than before the other platforms. So thank you so much.
Thank you. Do you have any question? I have a question for you. And which is the payload of the micro drone you use?
The what?
The payload.
The payload.
Yes.
In the smaller one that I show in the greenhouse, I think that was like 5, 6 grams, 10 grams, something like that. It's really, really small. But there are HD cameras that you can use for that. And for this one is, for example, the Mavic of DJI. Here is the camera. So this is the camera. And this is a 4K camera. So you have 4,000, 3,000 pixels.
And the maximum flight duration?
This, for example, the Mavic is around 20 minutes, 20 real minutes is used. And the small one, no, the small one I will say 8 minutes. But it's, I mean, this technology is right now, the market, and there are so many possibilities that they are improving a lot. So I will expect, and right now there are another ones that is the Air, that is like half size of this, of what you are seeing here. So it's between this and the other microdrone that I show, that will be around 15 minutes, for sure.
Other questions? Flavia, please.
Yeah. So the funny thing is that part of the industry really go for the selfie. Instead of take a selfie like this, just take the drone and you take a selfie from wherever. But also there are right now a lot of applications in Android or in iOS for the iPhones that you can make a planning. And they are growing up, so they will be even more perfect. For me, at the beginning, the weakness that can have these guys is the precise flight or the flight capacities. And some of them, when you're flying and there's a lot of wind, start to get crazy. But the other, right now, is they are doing really, really well. And the next point probably is that do not fly just by GPS. Also flight, thanks with the phone antennas for phones, that makes you more precise flight in that. So I think it will be one of the options for the future to be really, really precise.
Another question, please, Felix.
Yes, at the beginning you mentioned the problem of erosion after fire, and you mentioned the connectivity property. Can you explain a little bit more what you mean by
It's difficult. It's difficult for me because I'm not a geomorphologist. So Joan is here, is a colleague of mine, so we can speak later because I can tell you something, but it will not be good enough for sure. Sorry about it.
The connectivity is an index for measuring the potential erosion in a landscape, in a catchment, considering the boundaries of the catchment and the sink in the outlet. So you can see two components, the upstream component and the downstream component. That is detected from the detailed vision model or with more information? Yes. Only from the detailed vision model. Yes, the morphological feature.
Yeah.
Yeah, sure, of course. We have another minute.
Okay. No, thanks for the presentation, and I really think that micro drones it's a frontier for sure. I understand what are the potentials, but at the same time, I would like to hear from you something about the major limitations that we have with this kind of device.
The payload. So these guys are really small. The payload will be really small, but it's highly probably that in the future the guys will get smaller sensors. That means reduced weight of the sensors, and it's going like this. The Mavic, for example, that the one that you see the other day, I was checking some stuff, and they already some people get a thermal camera there. That is quite impressive because a thermal camera usually at the beginning of the time, well, beginning of time, no. Just 8 years ago, the thermal cameras were something really huge with a resolution really poor, and that was really difficult to maintain the sensor stable because each time that changed the temperature sensor itself cannot measure properly the temperature of a surface out of the camera. So, but I already see a small sensor. I don't know if it works really good or not, but they are growing really crazy. Super nice. Super nice. It's impressive. This, for example, this is the camera, and this is a 3D gimbal, and it looks you fly with these guys, and it's like moving. It's impressive.
Okay, thank you very much for your speech. Now we have to move to the next speaker. Is Martin Mokros from University in Zvolen, Slovakia, and Martin is going to talk about detection of forest wind throw areas by a manned aircraft system with RTK.
Okay, hello. My name is Martin Mokros, and I'm from Slovakia, and I'm partially working at Technical University in Zvolen and also in Czech University of Life Sciences. Today I will show you what is the some of our partially results that we are doing right now. And also I show you some results from past that we have done with UAV. But first of all, I have finished the PhD 2 years ago at Technical University in Zvolen, and I was focusing on terrestrial laser scanning for forestry. And right now at Technical University in Zvolen, I'm developing a multi-camera system that is based on Raspberry Pi computers. So we are developing something that is a really low-cost solution. That is the cost of the prototype is around 200 euros, and we have did some first tests with the University of Évora in Portugal. So it's working right now, but we will see in the future it's going to work, and we will develop more more cameras, 8, 10, and find a way for the forestry. And at Czech University of Life Sciences, there is a GIS specialist, and we are focusing on global changes and the impact of the forest ecosystems. But what is the important for this meeting is our focus on UAS, and I'm a forester, so we've found, I think, really good solution for foresters and the use of UAS for the forest windrow. It is very important in Slovakia to know the information about the size of the calamity maybe in 2 weeks after the calamity, maybe 1 month. In the regulation, they say you have to have the information what happened there till 1 month after the calamity. So it's not possible in Slovakia to do something like that, because now in practice the forester is going on the hill and just look on the area and then say, okay, this is this. But usually it's 2 times more, sometimes it's 3 times less. So the assumption of the foresters are not useful at all. Also, we can use satellite images, but the UAS brings really good information about the trees in the calamity, how they're laying, how they are on the roads, and they can do the management of the harvesting. For example, in this calamity, we have a situation that after 1 year they have found 5 hectares of forest stand that was laying and nobody knows. So it is really important to know the information really fast after the calamity and have the resolution to also plan the harvesting. Firstly, we have used Gatewing in 2014, and then we have decided to use EB Plus for this solution, because we have spent a lot of time to place the ground control points, and it is very important to make it very easy for the foresters and for the operators of the UAV. And the EB Plus has the real-time correction, so they're saying that the accuracy is plus minus 2 centimeters. But firstly, we didn't believe this accuracy, because it was for us, I think, really accurate. And we have decided to do some experiments, and we have placed around 60 points through all the plots, and we have compared the real-time correction versus ground control points. So in the second case, we have used some ground control points for the transformation, and then compare it between. And we have also decided to make one flight in one direction and then second flight in perpendicular to the first flight, to see if this is going to bring us something, or it is useless to spend the time and money to make two perpendicular flights. And not just for the accuracy of the positional accuracy, but also for the resolution of point cloud, and also for the digital terrain model, because as we know, it is very difficult to obtain digital terrain model from the photogrammetry in forested areas, of course. And also we have this flight during the leaf-off season. So we are hoping that the digital terrain model is going to somehow appear, but the preliminary results are showing that it's not that case, even for the two flights. Here are some results from the 2 flights. This real-time correction versus the ground control points. We can see there is some trend in real-time correction that the Z value, I think here's the Z value, and these points have higher errors. And when we use the 5 ground control points for the transformation, we have eliminated this kind of errors. And these points was on the area that the slope was very steep. So, but these are results from last week, so we are going to a bit deeper to find what's causing this. This is the results from the same, but just in one flight, and we can see somehow the same trend that the Z value is a little bit higher for the RTK, and we've compared 2 flights versus 1 flight just with the RTK, and we can see that the errors from 1 flight are a little bit shifted and the errors are higher. But we have to do some statistics to find out if this is significant or not. And here are some numbers with the root mean square errors. And we have, I've put there also the errors from the images. These errors are because if we are not going to use ground control points, at the end we have to say what is the accuracy, or the forester or the, I don't know, the one who is ordering this kind of stuff wants something on the end that this is the accuracy. But if you are not going to use ground control points, we have to somehow find out the way. So the images are geotagged, so when after the aligning, you can calculate the errors of these images after the aligning. So we can see that the errors are, I think, really impressive. And I think on the first side that when the RTK and ground control poles are used, the error is consisting more or less from the measurement of the ground control points. So how you click the point in the software, how you measure, because you have some error from the GPS, we have some error from the operator, a little bit shifting. So there is multiple errors that are combining in this case. So we will go to deeper and find a way how to get the information about these errors for the RTK ground control points. We have already published a paper that is focusing on DJI Phantom 3 and the accuracy from the ground control points. If we are going to increase the number of ground control points in different forested areas, if it's going to really improve something. Okay, so I will be a bit quicker. So these are the results from our research before EB was used. So this is from the Gatewing, and we have cooperated with the Technische Universität in Vienna, and we have compared 4 techniques to derive the wind throw areas. So we have used GNSS that is used by operators right now, but it is there are very bad results because in the first days it is very dangerous to go on the wind throw areas because you can get hurt, and also then they do just some generalization and so on. But we have done this measurement properly around the plots, and then we have used just UAS and the DTM and DSM, and then we have combined the DSM from UAS and DTM from airborne laser scanning. And we also have used the Landsat, the time series. So I will be a little bit quicker. These are results from the whole area, and we can see that there is no big difference. But the big difference was because this approach was semi-automatic. So here we can see the results just from the. I will finish in 1 minute. Just from UAS, that the red is the potentially wind throw area, and we can see where we combine the UAS and airborne laser scanning, the results are much more better, much more improved. And we have also calculated the volume of the fallen trees based on the area and the forest management plans, and we have for something around 5% that when we compare how many the number of volume that the foresters take to the storage, and they measure the trees, so we compare it with our measurements. Okay. So
Thank you very
thank
much,
you.
Martin. So we have 2 minutes left for questions. Please.
The unit of the air, the unit
It's centimeters.
Centimeters.
Yes.
and did I understand correctly, the best result was just geotagging?
Yes. If
Less the centimeter,
yeah.
not without
Uh,
ground control.
No. It was, but it was just the errors for the images, not errors from the checkpoints on the ground.
Just
Because
distances between 2 points. Positioning.
the position of the images, they have the images were geotagged, and after the aligning, they will a little bit shift. So the error of the shift between the images.
And that's GPS is from the phantom, if I understand correctly. It's just the GPS which is on the phantom. On the
It's the EB from
yeah,
the.
I get
They have real-time correction, so.
So we have 30 seconds left for questions. Please.
Take advantage of this. I think there is one question that is probably something that you have to address. Do you have an idea of what is the minimum number of ground control points per hectare that you would suggest for any survey?
We have found out in the study that the 5 control points are enough, and when you are
Per hectare,
increasing, you are not
getting any benefit?
you are not getting any benefit. But if you are not going to find these 5 points in the area that you will be, I don't know, under some tree or something, then you have problem. But if you are going to identify these 5 points, it's enough. But with real-time correction, I can say right now, based on the preliminary results, you don't need any of that.
But 5 independently from the extent of the area?
In our case, we have used small plots, and now we are do the research of 300 hectares.
I think this should change with the ratio between the geometric resolution and the extent of the area, not just the extent. But okay, and there should be some difference between errors at nadir and off nadir. Off nadir errors should be higher than at nadir. Okay, thank you very much, Martin. And we have to move to next presentation. Is from Nunzio Romano. He's a full professor at the University of Naples, Federico II. And he's going to have a speech on assessing the ability of hybrid poplar for in situ photo extraction of cadmium using
Okay.
heavy photogrammetry and 3D.
Thank you, Mr. Chairman. Hello, everybody. A couple of things about this presentation. First of all, please don't pose question about the use of drones. I am an end user. So I am an hydraulic engineer, I am an Vegetation zone hydrologist, so I don't know much details about the techniques of drones, but I would like to discuss with you with this presentation for two major objectives. One is to see the potential of using drones in a couple of topics. For example, contaminated sites. Yesterday we discussed with the working group about the topics in each working group, but I didn't see the use of drones for addressing issues in contaminated sites. This could be an issue that we can explore. Also, another issue could be fires, wildfires. This year we have experienced very severe fires in Portugal and in southern Italy, so the use of drones can help in this respect. And then the other objective of this presentation is just to show you a sort of how to design an experiment to have the potential use of the drones and coupling drones with modeling. And in my case, even though this presentation is within the vegetation topic, but also I will talk more about soil moisture, but again, this presentation is in between the soil moisture and the vegetation. Only at the end, I will say something about vegetation and the potential use of drones with the vegetation. And again, what I like is not to see separately the component of the environment, but from my point of view, I have soil, vegetation, and atmosphere as a continuum. So the idea is to monitor these three main components for addressing and to try to find some solution. Well, let's go straight to the problem. The problem is that we have, maybe most of you knows the contaminated site in surrounding of the Naples city, and sometimes some of this contamination are illegal, but I should say there are only some small spots of contaminated sites. The problem is that, so this is a very important area. It's an important area not only from the agricultural point of view, but also for tourism. So the basic idea is how to recover the area that was found contaminated. And again, the motivation that was were put in a founded life program is to try to give back the soil to the farmers, because you can use even other type of soil restoration techniques like soil washing, but soil washing destroy the soil organic matter. So there is no more fertility in the soil, and what you can do with this part of the site, you can use as shopping malls or buildings. This is not good, especially in that part of southern Italy is very with a very fertile soil coming from the volcano of Vesuvio. So the idea, the solution, is to keep soil alive. And one way to have that is to use the phytoremediation to restore the soil. So again, now the main topic of this presentation is how drones and modeling the water flow and solid transport in the soil plant atmosphere system can help to restore the soil. So, and this is the title of this life project that I have say we just received an award from the European community as the best life project founded in 2016 and 2017. and we will receive the award next week in Brussels. Well, so of course in this area we made the classic soil hydraulic characterization, but I want to go into details on that because I would like to discuss with you about this test site. This test site called the Trentola test site is a site, in 2012, this is the situation. There was a waste disposal, of course illegal. So what we did just to remove the waste materials and then made some measurement about the compounds found in this area, mostly are copper and cadmium. Well, then the phytoremediation was implemented by planting poplar trees with a very high density, 1 meter by 2 meters. So the uptake by root uptake was very intense. And this is the area just after the planting. So the monitoring devices in a couple of locations, we put these sensors at different depth in the soil to measure soil moisture and electrical conductivity and temperature, and also the matrix potential. So we have information about the water movement in these 2 points, and also about the hydraulic gradient, so for modeling and having information and modeling the water fluxes toward the groundwater. This is also another issue. So an issue of movement of these heavy metals from the vadose zone to the groundwater because the transportation of rainfall and other things. And then because of the LIFE project, we also try to export this to the public bodies and practitioners. So we decided to not to have very intense measurement about the evapotranspiration, but we use the dendrometers that measure the diameter of the trees. These can be linked to the evapotranspiration fluxes. So you model the evapotranspiration fluxes in this proxy and simplified way. But this is fine for this purpose. So this is the look is a picture of the monitoring devices, and this is the data logger, and these are the 2 points where we put all the sensors. Well, in a presentation before, the speaker talked about the connectivity index. Well, this is quite similar because using the drones, what is the idea? The idea to use the drones to have information about the accumulation of cadmium in the surface soil. And the idea, and so we have to check this idea, is to see if the concavity and convexity of soil is a situation where there is accumulation of cadmium. So using the drone in a very classic way with a micro topography, we have the DTM, and then we have 3 major catchments in this area. And then we computed the terrain index. For those who are hydrologists, you know the terrain index made by Bevan, or the clima terrain index. The clima terrain index means that you put also information about the annual rainfall in the area. So what we have, these are the frequency distribution of the terrain index, the clima terrain index. This is more a bimodal distribution, and this is more close to a normal distribution. But what is nice, we were able to find a correlation between the clima terrain index and the concentration of cadmium in the area. And this is nice, because what is the take-home message of this? That you can use this the information from the drone to design the sampling point for the cadmium or another compound concentration measurement, because they are very expensive. So you design the 2 minutes, okay. You design the your sampling sampling points in the best way, using, or you can use then a kriging, and then you can choose the best point where to make the heavy metal measurement. So this give you an idea of the use of a drone in this respect. And then we couple the 3D Richard simulation, and this is the initial condition of cadmium in the area. And this is what happened at your left. This is a bare soil. These are only simulation, and this is what happened in the cadmium concentration with soil with the poplars. Again, you see, of course, the positive action from the poplar trees in uptaking the component, a part of the cadmium concentration. And then, so coming to the conclusion, and an aid toward the vegetation. Because of course, if you use the phytoremediation, the other question that we pose, that the vegetation does not transpire in the same way throughout the year. So this means that if this is the rainfall distribution, and you have the potential evapotranspiration in green from the temperature for the local temperature, but you have an actual transpiration of the plant, especially from Mediterranean country, you have a stress condition, so you have less water uptake by the tree, so this means less uptake of heavy metal concentration. So again, the drone can give us very good information about the stress condition in the plant, and so our modeling and the effectiveness of using phytoremediation for in this situation can be even more effective. Thank you very much.
Thank you, Marcel. So we have time for questions.
No, yes, because we are streaming the conference, it will be better if the speaker answer the question from the microphone there. You don't mind, Nuzio?
No, it's fine.
We use the microphone for the questions. It's not the people is not hearing what, or
Okay.
not listening what the
Do we have
questions.
any question? I have a question for you. The evapotranspiration you calculated is actually correlated, or is a correlation with the dendrometers measurements. Okay. Do you have any time lag between these two quantities?
No, okay. I don't know. Okay, it's for. Oh, it's a very good question. I don't know if you got it. The use of the dendrometer for the evapotranspiration. Again, as I said, we use dendrometer just to transfer in a simple way how the practitioners or the public servant can use in a very easy way some very cheap sensor to have good information about the evapotranspiration. What the dendrometers does, you have the average evapotranspiration in the day, but you can use the variation in the diameter just to have a modulation within the day of the evapotranspiration. And of course, the actual measurement with soil moisture and matrix potential give the right amount of water uptake by the root, so you have the actual evapotranspiration. So you have again both the evolution of the evapotranspiration potential and actual within each days.
Other questions? Giuseppe, please.
You are assuming
you're assuming that the evaporation from soil is zero.
Oh, it's with a very high density of popular trees. You assume that it's not zero, of course, but it's less significant comparing the transpiration from the trees. Yes, good question.
Okay, thank you very much. We have to move to the next speaker. Is Victor Madrigal. He's from the Soil Conservation Service of Iceland. Okay. And Victor is going to give a speech on vegetation monitoring in Iceland using UAV.
Okay, so I'm not Victor, I'm Bryndís. We're taking this talk together. We're Team Iceland. So my name is Bryndís. I work for the Soil Conservation Service of Iceland, which is a public institute that works with soil conservation. A lot of revegetation, land management, and other things. Well, Victor, he comes from a company called Svarmi, which is a drone company that specializes in environmental monitoring. And how do we have something to? And just a little bit about what we're dealing with in Iceland. This is Iceland. So we're one of the most sparsely populated countries in Europe. Most people live around here, and then we have towns around the coastline. And we don't have a lot of agricultural land either. It's like 2.5% of the land. Forestry is 0.3%, and we have 1.5% forest. So basically we have a lot of rural areas, a lot of natural ecosystems. But even they're natural, they're heavily utilized. We have like over 1 million sheep that graze our country and are roaming free around the countryside every summer. And we have had in the past and do have now a lot of problems with land degradation. I mean, we have a special institute for soil conservation, and that's because we have had a lot of problems with that. But even though we have a lot of we're using the land a lot, we have problems with land degradation, we don't really have any good monitoring system for the vegetation and soil. We have a forest monitoring system, but that's 1.5% of the country. But we're changing that. At the moment we're developing a national-wide vegetation and soil monitoring system, and this is actually funded by the stakeholders. Most of the funding comes through the agriculture subsidy system, because the farmers, the sheep farmers, saw that they needed this information to be able to use the land in a sustainable way. And we're in the development phase, but the monitoring will start next summer, or the summer of 2019. And this is a little bit just about the monitoring program. So we'll focus on ecosystem functioning and structure, vegetation cover and composition, ecosystem resistance and resilience, and those nutrient and water cycles and energy flow. And we will do it on several spatial scales. We can't go everywhere, so we will use satellite images to monitor the whole country. We will have a grid of target sites all over the country where we will do drone imagery and monitor the ecosystem with that. And then we will do detailed on-site measurements, but that's very costly and time-consuming, so we can only do that every 5 or 10 years. And then we will also work with stakeholders to let them monitor their land. And one of the big challenges we have in this project, and what we have been talking about a lot today and yesterday, is the linkage between different scales. How can we improve satellite images using drones, and how can we improve the drone images using detailed on-site measurements and so on? And I think Victor will talk about that, so I give the word to Victor.
Thanks, Bryndís. I apologize for my voice. I'm a bit sick, so hopefully I will perform good. So I will just provide you, how much time I have left, first of all? Okay, cool. Yeah, so I will present you 2 examples of how in swarming collaborations with national institutions in Iceland, like the Soil Conservation Service or the Marine Research Institute, we have sort of combined and linked satellite images with drones and soil measurements. One of the case studies is in Breiðafjörður, where we classified seaweed, Ascophyllum nodosum, using Sentinel-2, Landsat, drone images and field measurements. Another one is in a glacial outwash plain in Skeiðarársandur, where we are collaborating with University of Iceland and the Soil Conservation Service for studying the bird colonization going on there. So for the Breiðafjörður, what we did there, I'm not sure if you can see it here, but the Marine Research Institute, the workflow for mapping the seaweed was just basically to digitize aerial images. So it took them quite a long time, like 5 months to do this, and it was not very consistent because Ascophyllum nodosum is found in the intertidal zone. So you need to have images when it's perfectly like low tide, and they need this classification for the stakeholders to know how much they can harvest. So it needs to be very precise because otherwise farmers will be angry if you don't tell them the right number of tons that you have of seaweed. So the workflow that we developed, we used different sites in collaboration with the Marine Research Institute, where we surveyed with drones and in low tide conditions, also like synced with Sentinel data, passing those days that we were mapping, and also during the low tide. So we had like the window for selecting the images was not very big, also because Iceland used to be, it tends to be quite cloudy. But what we did basically, we use the scale one. We collected field samples of algae, of biomass, and also point samplings of where algae was. Then we collected the drone images and also classified in 2 types of seaweed because we were only interested in one. And then we used like an artificial neural network to train Sentinel from the drone images. And the results, this is one of the RGB images, but we use multispectral, and we train for discerning these 2 algae. And then this was the results with Landsat and Sentinel. So basically what we achieved with this, we did this in the processing time was like a week, and the accuracy, final accuracy of the classification was about 85%. So it was quite good for the area and the conditions. And then for Skeiðarársandur, what we're doing there is like a very big project lasting for 3 years. In the outwash glacial plains, and this is like Skeiðarárjökull in south of Iceland, and all this plain here, 20 years ago, no one knew that there was any vegetation growing there until the researchers Thorel and Kristin and also Bryndís, they found out that there were some trees growing on in Iceland. So they found that there were some birds colonizing there, and no one knew exactly why and how it was occurring, what it was and what it was spreading. So we collaborated in order to bring drones into this to map it. So here we are with our fixed wings that at the time we mapped about 70 square kilometers of the plain. But the thing is that we needed to 40 flights, and there is a lot of course, problems with this in terms of radiometric calibration, but we sorted out also, and I can talk to you about later also as well. But now we extended the flight time of the drones. Before we were flying for 30 minutes, now we can fly for 1 hour. So we could have just reduced a lot the number of flights. These are some of sample images, and what we were studying basically is looking where the birds grows, why, how it's related with kettle holes. Those are old deposits of ice from old glaciers. And yeah, and basically we created this orthomosaic of 130 gigabytes. And what we did, we classified using object-based image analysis, and used some students during the summer to look at basically if what we were classifying was good or not, to create an error matrix. So we took like point samples all around the area. So the idea with this was to, once we have the drone image and we have like the classification classified in birds, other types of plants, moss, and types of grain size, and we have also the topography derived with the DM and the DDM. The idea was basically to do a geographical regression analysis and now look at the birds as an independent variable and look how it's related with everything, with the slope, the aspect, and other types of vegetation in the area. And then once we got the classification done, we looked at the transects where the density was the highest, and now we will monitor those transects for the next 3 years. So we will basically be using, that's a map of the density of the birds, so we use those for basically knowing where to map. So what we will be using is our own in-house created drone. We also create our own drones, so we will be continuously mapping this area with this type of drone that has 2 RTK GPS and has an integrated Sequoia and a thermal radiometric camera, and then we also have like a octocopter, and this can last about 30 minutes of flight according to our current estimations. So we'll be using this continuously through the summer to create the high resolution spatial datasets, but also high temporal datasets. So this is one of the ideas to look at the microscale. So we are looking here at the image taken at 20 meters height. So the resolution is about 0.5 centimeters per pixel. So what we're looking at here, it's 2 minutes, okay. So we're looking at here, it's like multispectral imagery and also thermal imagery in order to create basically like a sort of to look at how it's basically related across the time with many of the different variables in the area. And we as well are cross-referencing this with measures in the ground, soil samples, hygrometers, also like PAR sensors, in order to build from using the ground truth, so using like scale 2 of drones, using the scale of the ground, and then upscaling to create reflectance maps, chlorophyll maps. Probably we're working now on a light use efficiency-based gross primary production that we could probably scale then to satellite measurements. Yeah, that's some of the transects that we're working on, and the thermal imagery, the NDVI, the soil moisture that we are doing a parameterization between NDVI and thermal imagery, but we are happy to learn other ways of doing it. So, and that basically is sort of summarize what we're going on, what's going on in both of the sites. So, yeah. So yeah.
So we have time for questions.
Yeah.
I would like to ask you. I would like to ask you. I've seen that you have a sensor measuring the downwelling solar radiation.
Yeah.
And then also calibration target on the
Yeah.
ground.
Yeah.
Are you using both of these information or just one?
We're using both. Yeah, and we're also using. We can install pyranometers in drone, upward and downward facing to calculate also albedo. So, yeah, and that we use for including glacier mapping.
Other questions?
Thank you. Nice presentation. I wanted to ask you about that neural network model on the Sentinel, I believe. Were you able to use the model on time series of Sentinel imagery or only on one? Okay. Okay, because this thought that maybe you were able to do it on the time series. That would be much more interesting. But
The problem with this project is that we needed the Sentinel images to be taken at low tide, so we could see the full extent of the astrophilum, and this was very difficult in Iceland, especially. So we had maybe 2 images per year.
okay, I see. I see.
So it's it's very difficult.
Okay.
So when you were using the Sentinel image and the drone image for the classification, were you using the absolute radiometric measurement, or were you more using special patterns? How was that somehow calibrated to each other?
I was basically trying to use the same bands, between the drone sensor and the Sentinel, and use just basically the reflectance values.
Okay. Okay. So you assume that they measure the same thing, but you have to do all those corrections, I guess.
Yeah, I mean, it's a huge assumption that I have to take, but there are others. We are thinking about buying a camera that you can, it's closer to the bands from Sentinel, and then we can maybe perform that on that.
Yeah.
Just a question? It's a brief question. Regarding the use of geographical regressions, I believe that I saw something about this. So you are using this statistical technique in order to solve the interest scale, or even for relating the different parameters between vegetation, soil, and so on. Uh-huh. Okay, thank you.
So we are moving now to thermal images using the view. And again, we have 12 minutes for the presentation and a few minutes of question.
Okay, I'll try to speed talk you through this presentation. So my name is Jesper, I'm from the University of Copenhagen. And to put my work into perspective, I work with small plots. You've already heard about the use of UAVs for breeding. And that's basically what I work with. It is UAVs for breeding, working with private breeding companies. And our projects take place in the entire Scandinavia. So we have a Nordic plant phenotyping network. So we have a network also covering Iceland, the Scandinavian countries, and the Baltics. And here we work on especially implementation of UAVs for screening purposes in a breeding context. So a lot of private breeding partners and universities in the Nordic countries are collaborating. So far we've finished 3 years, and now we're continuing for the next 3 years. The case I will introduce you to now is just a small part of the phenotyping work we're doing. It's called RADIMAX. It's about deeper roots to increase uptake of deep water and nutrients. I hope I can convince you in the end that this relates very well to drone imaging. We'll see. It's all about increasing root depth. So we've seen in previous experiments that, for example, a wheat plant, we can find genotypic differences in root depth of up to 30 to 40 centimeters of differences between varieties. And that's a lot of resources that you can exploit in deeper soil layers if you have these 30 to 40 centimeters of additional root growth. And in Denmark, we do experience drought stress, so we would like to exploit all the water in the deeper soil layers. So this has become a huge part of research in Denmark. It is to breed for deeper roots. And deep roots is a genotypic trait that we can select for. So we just need to find the genotypes with the deep roots. But how to screen roots non-destructively without having to dig into the ground. We also want to screen the roots during a season, so we want to continuously screen them without harming the plants. The only way we could figure out was to build a facility. The facility is also called RADIMAX. So we constructed that 2 years ago. It's 4 units here, and each unit is 10 meters wide and 40 meters long. These tents here, they are rain-out shelters. They can be moved forth and back, so when it starts to rain, we cover the units to prevent precipitation. So when we want to initiate drought to see water uptake, then we start to move these guys when it starts to rain, and we remove them again when the rain is over to continuously have a natural illumination. But this is only one part of the facility. The most interesting thing is the below ground part of the facility. So now we'll take a look at these 2 units from a cross section, looking from here. Then they look like this. So there's this pathway. That's this pathway you see here. And then each unit, they were 10 meters wide. So the interesting thing is now, we made an excavation. So we dug out, this is how it looked like in this unit. We dug out this slope. So we simply removed all soil because it was too heterogeneous to study roots in. We wanted to put in homogeneous soil. So we removed it. And as part of that, we designed underwater a subsoil irrigation system. So down here, there's a gravel layer, so we prevent all capillary forces of water from coming up. And then we installed irrigation system based on drip irrigation and water absorbing materials. And we can make a gradient of water down here. So we can actually water, creating a gradient following this slope. The idea is that we stop precipitation with these rainout shelters. The plants utilize all the water that is available in the root, in the soil. And in the end, where there's no more water available, then it will only be the genotypes that have roots deep enough, 3 meters, to go down here that will take up water. The other ones will become drought stressed. So we expect, and we do see, that plants that have shallow roots start to wilt up here. And plants that have deep roots, they can continue down, so we can start to pick out our varieties based on that. But we also want to have a visual proof of concept. So we also installed glass tubes. It's the ones you see here, where we can put down cameras and observe the roots. That's me installing all the glass tubes. 150 of those, all the way down here, following the slope down so that we can study the root, if the root is coming down there. So now we can irrigate from below and we can study roots. So if you take a look at one unit from this side, then you can see this is all the glass tubes coming up. So we put down cameras here, 25 centimeters of different distance, and then we plant a genotype. This is grasses. Then it's different genotypes of grasses that is planted, and then we monitor the root growth, and we monitor can they take up the water during the season. And then when we when we think time is ripe for it, then we shut down for irrigation from the top, and then we start to irrigate from the bottom. That's how we try to select it. The question is, how do we monitor this drought response up here on each line? Well, we could, as you saw, they used micro drones in the greenhouse instead of installing some XYZ camera system. We didn't have the money to install any camera system to observe this, so we use a drone instead, and then a piece of software to make mosaics. So we fly at low altitude, and then we make mosaics of each unit, and then we analyze that instead. So we bought a DJI Inspire drone. We put on a multispectral Sequoia camera to look at near indices. We have a nice color camera we can use, and then we can exchange that with a thermal nice XT camera with a high resolution. So this is the working tool to try to look for drought. So last year at the 4th of July, we looked at, this is barley, different varieties, that's why they differ in color. We had to look and see, can we see any drought symptoms on any of these varieties? So first of all, we measured on the ground. So we measured each red square here, that's 2 different lines, so that's 2 different genotypes, 2 here, 2 here. 14 different lines, 14 different genotypes of barley, where we measured stomata conductance, so how much do they transpire. We measured here in the middle, where we expect some of the varieties will be drought stressed because there's a long way down to the soil water. And we measured here at the edge. And at this time point, we had shut out all rain for 1 month. So we had to see, does it work? Now, if you focus on the green bars first, that's the measurement out here at the edge, and this is the 14 different varieties, 14 different lines we measured. This one is over here, and this one is over here. As you can see from the green lines, there's a huge difference actually between genotypes on how much they transpire. The higher this number is, the more water they transpire, evaporate. So there's a huge difference between genotypes. How much do they transpire at all when they have access to water? The next thing is, if you compare it to the purple line, that is the measurement in here, then you see some genotypes, well, there's no difference. It can take up water here and here. But for example, this one, this cultivar, there's a huge difference on how much it evaporates out here and how much it evaporates in here. So it's affected clearly. We believe it cannot take up water from the depth. So this is how we can screen and compare the different varieties. And now the drone comes into the picture, because at the same time we did some thermal, multispectral and color imaging, also on the 4th of July, the same pit. And from the RGB image we could see nothing but the color differences between varieties. There were no wilting or anything at this point, even though there is a difference in transpiration. So if you focus on this one up here first, this is from the multispectral camera. This is this classical normalized difference vegetation index, this NDVI. So green color is high relative biomass and yellowish is low relative biomass. And we don't see any yellowing in here in the middle. So it doesn't seem that the crop is affected. These squares just show you where we measured stomata conductance. So it doesn't seem to, we can't see anything from the NDVI, but when we started to look at the thermal camera, 10 degrees up to 30 degrees, we can see there's a clear-cut signal that they start to heat up when you move into the middle. So a loss of transpiration increases temperature of the leaf. This is what we wanted to look at. And also we see that some varieties are cold all the way in and some starts to get warm earlier. So from the temperature we can see there are differences, and that's what we want to see. If we scale it up a bit, this is the one you just saw, where you can see the differences. This is the same unit just 3 weeks earlier with the thermal camera, and you don't see the same trends. You see some trends are starting to appear. Over here, I don't know if it's heating up the plants or if it's noise. That's something we have to work with. Everything is taken in an altitude of 30 meters, and then this is a mosaic stitched together of different thermal images. So we do see something is happening. There are potentials here. How much time do I have? 5 minutes. I have to slow down. Okay, so we believe there are some potentials here that we need to look further into. But these are only nice to have maps. They're only illustrative. We need to have maps. We need to get the information out of them. So what we are developing now is this piece of software we call the plot cut. So this is a software, we also use it on our plot experiments in the field. It's a software where we just enter a matrix of the ID values, the numbers of the plots we want to extract. In this case, it's just the ID values of every single row down there. And then this piece of software will distribute this grid that you can see. We adjust it a bit, and then the grid fits every single row out there. Then we press execute, and then it will cut out each row. This is 3 different cultivars, the thermal signature cutout. And then we will put it into, most likely, RStudio, as it's a free open software to do the image analysis and the statistics. We also put it into MATLAB, where we have an algorithm that can say, it calculates the distance here and calculates the temperature, pixel temperature per distance. So then we can start to compare, okay, this one is cold all the way through. Okay, this one started to heat up here. This one started to heat up here. And then do statistics, dose response curves or whatever, to see when do they start to respond in the thermal signature. So that's under development now, and when we finish that piece of software, then we'll be able to take these numbers and compare them to stomata measurements and also to routing depth. So this is I see Radimax as a playground to test drone imaging, to test different types of drone imaging and compare them to ground truthing and also route measurements in the end. So we're going to continue this work in 2018 now. There are 3 core groups doing research out there in 2018 on winter wheat and on potatoes in the 2 we're going to grow out there. We're going to measure root depth, that's one group. Another group will focus on measuring on the plants, different types of measurements on the plants to detect drought. And my group will do frequent UAS imaging morning and noon over a longer period. And then we will combine roots, canopy, and spectral thermography RGB. But there are a huge amount of challenges. I hope we get to discuss some of those during this workshop, and I also hope to solve some of them during this very nice cost action, because surface roughness, different cultivars, different height, wind, these shelters may cause turbulence and wind in general, and sun and relative humidity. All these factors can affect the temperature of the leaf, make it fluctuate. So you're not studying drought anymore, you're studying environmental impact on your plants instead. So these things are things we need to cope with. Temperature effect from the concrete and the passages out there. Background temperature, how to segmentate the soil away from the crop lines, because the soil will have another temperature. It will mess up the entire picture. Are we going to work with stress indices or only the canopy temperature? And then this entire procedure of image analysis, photogrammetry, radiometric correction, resolution, altitude, these things, we have to look at them as well. So it's quite overwhelming. And that's it for me. I won't say anymore.
So do you have any question?
Hi, amazing work. I have two questions. The first question is that in the field, you are considering the effect of the boundary layer, because the point is that with the boundary layer, so is the exchange between the plant in your surface and with atmosphere. So in the inner parts of your field will be, the tent will be warmer than the outer part because the exchange is more easy. Are you considering this, this effect?
That is one of the effects we will have to consider, perhaps also in the design of the field experiment. How do you randomize your plots, and do you have guard plots around the entire field so that you can get rid of that? So it's got something to do with the planning, and then I think it's also got something to do with the acquisition of pictures and then taking these factors like the boundary layer resistance into a modeling perspective. It's difficult, and
yeah.
I don't think I can answer the question more clearly because other people will work with that. But yes, it's one of the environmental factors that will make the temperature fluctuate, so that you're not studying drought, then you're studying other things.
And another point is like, I see that you have different levels of transpiration, and there are huge differences between them, so that implies important difference on temperature if the stomatal conductance is the main factor driving the temperature of the plants, but in some cases it's not. When you have high humidity and low radiation, the transpiration have really lower effect, or we expect that we have really lower effect. My point is that the plants get under really drought stress in your experiment, or not?
They will be drought stressed,
okay.
Really drought stressed.
Okay,
but the problem is water pressure deficit, for example, with a high relative humidity. That's difficult to cope with. Yeah. Clouds, so that you really affect the incoming radiation. That's another huge problem. So we'll have to figure out how to deal with that and make the correct protocols, and perhaps we will only have 10 days to measure during a season.
Yeah. Because the point then is that if they are really under drought, that means that the water content of the plant will change between in optimum conditions and the drought part. So if the water content of the plant change, that means that the emissivity of the body of the plant, because the calculation of the temperature is based on the Stefan-Boltzmann equation, that an important factor is the emissivity of the body itself. So if the water content changes in the plant, that somehow also can affect to your final measurement of the temperature. So in a lot of crops it's not a problem, because like for example the vines have to be really bad to get a really big change on the relative water content of the leaf. But in tomatoes or in grasses, there can be important change on that. So I don't know if you are also checking this stuff. I don't know how to solve it as well, but I think it's important.
No, I know we have greenhouse experiments where they're looking at the emissivity on different plant species and how much that means when you start to drought stress them. In Radimax, we'll have to see how important it is for us as well, because in a breeding perspective, in Radimax, they would look at the 150 rows and then they would pick the 20 best and skip the rest. And they would say to me that exact numbers belong to publications. We want to take away the worst and keep the best. So in that case, I don't think the factor or those factors are that important. I want to have a timeline and then follow them and then start to see when does the small changes start to appear, and then when they become very drought stressed, then perhaps what you're talking about will be more of an impact factor. I don't know, we'll have to see, but
for sure if it didn't change the relative water content of the leaf, it's not a problem.
No.
Sure. Thank you.
Okay, I have a final question for you, and I missed which kind of acquisition you're doing within the glass tube.
Well, in the glass tube, we have developed a trolley with 4 multispectral cameras that we lower down to the bottom of the glass tube, and then an engine will pull them up stepwise, take a multispectral image, and then we have a MATLAB program that can distinguish in a multivariate image analysis between root reflectance and soil reflectance,
So
and
is
then
that
distinguish it.
an active system?
That's an
you are-
active system. And then we have added to it a hospital algorithm that's able to distinguish blood veins. Blood veins look like roots. So we add that to the system, and then we can distinguish roots from soil, and then we can see when the root touches the glass surface, we know that they're there, and it can be done automatically. And then we can study root depth.
So thanks for your very interesting presentation, and now okay, we move to Maria Tsiafoli from Aristotle University of Thessaloniki in Greece. So from below to above ground, using an upscaling and upscaling the bio-indicator potential.
Thank you for coming to this workshop. I'm from the Aristotle University of Thessaloniki in Greece. So my expertise is in soil ecology, and I'm interested in food web structure and diversity, in nematodes and ecosystem services. But I also have worked in issues of biological conservation, protected areas, habitat types, and monitoring. And I'm not telling this because I want to talk about myself. I want to make an issue of the scale. And I've realized, working in two different scales, that there's something missing. So when I'm investigating soil samples, I really have a knowledge of a handful of soil. And when I go to the larger scale, I don't know what is happening below ground. But here is the level of many ecological functions. Thank you for the previous presentation. And this is important to know. So above ground is important, but below ground is also important. So the outline of my speech has two main chapters. The first one deals with importance to know what is happening below ground. The second one has to deal with the bioindication potential of organisms that live below ground, of soil biodiversity. And the third part is I'm questioning if there is a way to upscale information provided by soil organisms to larger scales that are important for management. So, as you probably know, below ground soil is important because it provides a lot of functions. It provides a function of carbon sequestration, climate regulation, nutrient cycling, and so on. And it enables us to live on Earth. And we have to remember that soil is where food grows. So this is an important reason. In a recent review, soil has been placed in the center of almost every ecosystem service. And this review highlights the need that new research should focus on soil functional capacity of organisms living in the soil. So, okay, to many people, soil may be lifeless. It is actually to the bare eye, but it inhabits over 1/4 of living species on Earth. Professor Setala from Finland always says that the giving soil is a living soil. Soil is not important in terms of species diversity. It has a lot of biomass of organisms. So just to mention that in 1 hectare of soil, you can find 2 tons of bacterial biomass, which is more than the cattle grazing on this area. So the decomposition is the main ecological process in soil, and organisms are organized in a food web. food webs, in complex food webs, where they process food. It was known that they significantly contribute to soil functions, but only recently De Vries and collaborators showed and proved that properties of soil organisms, of soil food web, the characteristics of these food webs explain significant ecosystem functions like ecosystem services, like carbon sequestration and nutrient cycling. So, soil biodiversity also has been shown to regulate above ground biodiversity, determine ecosystem multifunctionality, and it is also significant for human health, and is significant for optimizing the delivery of multiple ecosystem goods and services in agricultural ecosystems. But there are a lot of threats to soil biodiversity. As you can see in this map, there are a lot of red areas in Europe where soil function and soil biodiversity is threatened. And here you can see in this graph that the threats are mainly from arable land, from agricultural land use in general. So, and here you can more detailed see that when you intensify agriculture, then you can lose species. You have here in the x-axis, where is the pointer? In the x-axis you have the gradient of intensification, and you can see that groups of Collembola or rebutted mites in the middle and earthworms steadily decrease with the increase of intensity. So I hopefully have convinced you that soil biodiversity is important and should be included in monitoring procedures for future conservation strategies and management efforts for natural but especially agricultural ecosystems, for ensuring and optimizing the delivery of ecosystem services. And just to mention here that several CAP subsidies are given to farmers for improving biodiversity and soil conditions, but these treatments are not assessed in terms of soil biodiversity. So what is the bioeducation potential of soil organisms? There is an enormous variety, there is an enormous complexity, and as you decrease in body size, you have a decrease in abundance and diversity. So this is a problem. Fortunately, there's a group of animals, of soil animals, of nematodes, which are worm-shaped. They contribute significantly to soil nutrient turnover, and they occur everywhere in high abundances and diversity in every soil. So they also have the characteristic to react rapidly to disturbance. When you have the model, this is a simplified model of the soil food web, when you have take all the organisms away, but leave the nematode, then you have a representative group in each trophic level, and you have a representative group of each possible trophic role. You have nematodes that are bacterial feeding, fungal feeding, omnivores, predators, and unfortunately you have also plant feeding nematodes. Many of them are parasitic and they cause damage to plants. So you have to know what the load of plant parasitic nematodes is in a soil. So because of this high functional diversity of nematodes, they are really the most preferred bioindicators of soil conditions. And they provide useful insights of soil functioning. They can tell you if you have a degraded soil, enriched and depleted soil. And they also give you early warnings of what is going to happen with your vegetation. So they have been used in some cases, like in the Netherlands, for national monitoring systems. just an example how they nicely respond to land use. Here you can see in the x-axis you have years of organic management, and you have one index, the plant parasitic index, which is the load by plant parasitic nematodes. Nicely, the index decreases with years of organic management. And here's another indicator, which is the form of nematodes. The form of nematodes changes with increasing land use, the gradient of the x-axis. So, there is a biodecation potential of soil organisms like nematodes, but unless you are able to examine 5,000 or 10,000 samples, you have to upscale this bioindication potential for in scales that are important for assessment, conservation, restoration, and so on. But is this possible? So in a study, because we had this in mind, we had a study when we examined nematodes indicators, community indicators across an entire landscape. So there's no time to explain the models, but the most significant we found was that nematodes not only respond to land use and land use pressure, they also respond to landscape characteristics like altitude and vegetation cover. So each nematode knows where it is. In another study, based on the knowledge that temperature defines biological metabolism, enzyme activity, and reproduction, we monitored temperature across the same landscape and calculated metabolic footprints. Metabolic footprints are the carbon, is the measure of carbon metabolized by nematodes, by the different functional groups. So there is also no time to explain the models, but we found that carbon is differently metabolized across the landscape. You have slower decomposition when you have fungal-dominated channels, like you have in areas of low vegetation, and you have faster decomposition when you have areas in higher altitudes with higher vegetation. So the most important, though, is that we found that our models could predict the nematode metabolic footprints for sites that we didn't measure. So this gives us a great potential to upscale information, to make interpolation, and then make maps of the soil functional status of an area of a size of a landscape. So, I need a minute. So, their bioindication potential can be upscaled by using parameters at larger scale that are linked to soil biodiversity aspects, like in our case, the characteristic of nematode communities, and by applying methods of modeling and interpolation. And drones, I've never used them, but I believe they can help by providing detailed data. And I already heard some very interesting presentation of parameters that I was not aware that drones measure them. So as a takeaway message, I would say that for ensuring and optimizing the delivery of ecosystem services, we should first take into consideration soil biodiversity, make use of the bioindication potential of representative organisms like nematodes, and upscale this bioindication potential by using parameters measured at larger scales that we found or that we will find to be linked to soil biodiversity aspects. Thank you very much for your attention.
Thank you, Maria. We have 1 minute left for questions. Okay.
Thank you for your talk. I just want to mention that one of the parameters to measure the soil biodiversity is organic matter, of course. And we just found that there is a very, very strong variation between one soil to the other. It's a paper that will be published in 2 weeks in Geoderma. I suggest that you will take a look on that, and maybe you should gain some output out of it for the next mapping of your area, because it is very, very strong related to the soil type, soil order by the USDA.
Yeah, this is very interesting. Thank you.
So thank you, Maria, for your presentation. And we have other two speeches. The first one is from Ivalo Tsvetskov from Sofia University in Bulgaria. Assessment of selected urban forest parks.
Thank you, Mr. Chairman. Thanks to the local colleagues. I do appreciate your efforts put in organizing this event. I'd like to say some words like a preface to this presentation. There is a small mistake in the program because I'm not representing the Sofia University. I'm coming from the Department of Forest Genetics, Physiology and Plantations of the Forest Research Institute. I have a strong background in biotechnology, but in recent years we managed to get some national funds for establishing experimental plantations for general assessment of bioproductivity of some fast-growing forest species like black locust, willow, mostly poplars. And I would like to say also that I'm not drone end user, and I'm not deeply involved in this story. I'm just presenting the results from my colleagues. I'm going to tell you some more words about the project we started this activity with. Actually, speaking about drones, so we are more or less newcomers in this field. The story started 2 years ago when our Ministry of Environment and Water Resources commissioned our institute to lead a project together in partnership with the Norwegian Institute of Bioeconomy, Sofia University, and the private firm called it Geographica. The project was devoted on mapping and development of indicators for assessment of the urban green infrastructure connected with the ecosystem services they offer. So I'm going to present you a very small part, a fragment of this project, and this is devoted on the assessment of vegetation, and at the same time it's a part of the another study inside the project aimed at integrated assessment of urban green infrastructures together by using drones and cross-validation by in situ observation. So it's clear that the knowledge about urban green infrastructure is quite important, and the perspective of the years to come, the rapid urban sprawl generates a need for establishment and use of adequate system for monitoring of the urban ecosystems. This is the aim of the study. As I said, this is a fragment of the bigger project. Carlu is a small city situated in the central part of the country. 7 different subtypes of urban ecosystems are defined inside of this project, and I'm going to speak about the G5, which subtype is urban forest park, which is the object of this study. 4 study areas were defined. most of them are parks. As you see, the first one, this is Apostol Gura. It's a forest in Bulgaria. It's a park. It's a city park. The second area, this is the central part of the city, and the area 3 and 4 are also parts, hunting park, and the other, it's a green zone around the natural waterfall close to the city. These are technical details about the devices which I use, but I said I'm not an expert. I just to prevent some questions, because I'll not be able to give you more technical details. At the end of my presentation, you can see that it's a part of the paper which is in press. So if somebody is interested, just let me know. I'm gonna send him a link to go in more details. As you can see, multispectral camera of part integrated with the specialized professional unmanned aerial vehicle system of type Flying Wing was used in this study. They start RGB channels. The focal part, as I said, of this study, this is the assessment of NDVI. These are results in short. The first study area. You can clearly see on the map that the high value of vitality of the vegetation covers, as well as those with the lack of vegetation, is also in satisfied or bad conditions. Almost 50% of the studied area of the vegetation have the index more than 0.75. But also you can see these red spots which are with which are related with the poor vegetation. This is the real center of the city. And you can see that this vegetation is mostly fragmented, and around 50% of the territory is without vegetation cover at all. At the same time, 50% of the central part of the city has index higher than 0.75. The study area, again, you can see this is a park. It's normal that it's expected that there are big zones with a high NDVI indices, but also data analysis shows that there are some spots with bad vegetation, which is shown on the picture. And the last study area, it's characterized with a relatively good condition of the vegetation, in which more than 40% of the whole territory has the index values above 0.7. As a conclusion, the results show that the implementation of this innovation technique could be used in such areas. Just a helpful tool, because I mentioned it that this study was followed by in situ cross-validation by in situ observation, and both methods used together could be very effective support tool for decision makers. Thanks for your attention.
Thank you. So we have plenty of time for questions. Salvatore?
Thanks for the presentation. There is a big question here, that is the comparison between it's working between satellite and UAV UAV based data. I see that there is some agreement between these two surveys. Do you have some insight about the internal variability and how the two datasets compare in terms of what is the level of detail explained at the pixel scale for satellite? What is the upscaling procedure that we can implement in this field? Just an idea. I know that this is a hard
Unfortunately, I've no idea because I'm a bit stepping aside, and I could say, I mean, I could send a link just to read the paper. Probably you have better imagination of what we are doing now because it's a very fragmented research. It was devoted just to present you some study devoted on vegetation monitoring, just like illustration.
Do you
But
have?
yes,
Sorry.
but well, I could say I'm happy because as a result of this project, we are co-owner of a drone together with the firm Geographica, and we have a contract for using this device for the future 10 years. So it sounds for me optimistic. Especially my interest and my motivation to join the action is related to the opportunities these innovation techniques could give us for doing phenotyping and phenology research of forest trees in a more efficient way.
Do you have any limitation to fly it within the urban area in Bulgaria?
I think there are, and what I know, they're just preparing new rules.
Thank you very much for your speech.
You're welcome.
So now we move to the last presentation of this session. It's from Peter Dvorak from Bern University Technology from Czech Republic. Alien plant species detection and monitoring.
Thank you. Good afternoon. I hope we'll all need to see some sun and perhaps also food, so I'll try to keep it quick. So I want to speak about invasive species detection with UAVs. We are working on this project with 3 parties. Institute of Botany of Czech Academy of Sciences. They are the experts on the actual invasive species and ecology. And Josef Bruna is here with us today, and Jana Millerová, who is also an MC member. Unfortunately, she couldn't come because she is on her Fulbright stay in US, but she'll be able to come after summer. Okay, so that's the classification and the actual ground truthing and the overall design of the whole campaign they are doing. GISAT, it's a private company. They are experts on satellite data, and they also create GIS so that it can be presented to the end user, our results. And finally, we like to fly our airplanes, so that's it. I'm coming from the Institute of Aerospace Engineering. We've designed and built quite a few airplanes, actually, so we are also doing some space stuff. It's not too important for us at this point. Important are UAVs, so we have started with design and building UAVs around 10 years ago. This is 4.5 meters UAV, our first one. We don't use it much anymore because, I mean, for visual line of sight work, you don't need such a beast, so it's idling in the warehouse. So this is our first platform used for image acquisition. As you can see, this is GoPro 1. Actually, I've been told that we were the first ones to supply fisheye imagery to Pix4D company in back 8 years ago. So obviously we don't use these type of sensors anymore, but they based on this they developed a special plugin for fisheye corrections. Okay, we are working with archaeologists. This is an example of Roman settlement in southern Moravia. Also, we are integrated in a local or like first responders. We help to fight them, you know, fires and stuff like that. Can I ask you for the video? Yeah, this might be of interest for some of you. We have also developed a ballistic recovery system for UAVs. So. Yeah, so the system is now commercially available. To our knowledge, is the lightest and fastest recovery system that you can get. So for those of you who've got like expensive sensors, it might be interesting. This is just a side note. This is my personal hobby. I like to play with boats, and I fitted autopilot to a boat, and I also fitted the sonar. So it can give quite interesting results for mapping, you know, the bed of water bodies. So I think there are some of you working around water. So I would actually be quite glad to hear whether that might be of interest for you, or whether you are using similar technology. Okay, so now back to alien species. Why do we want to concern ourselves with them? They are dangerous, you know. Not only to humans, but also to landscape. And as you can see, they let's say emanate and grow and spread. And once they are there, they are very hard to fight. So we need like new and effective means to monitor them in the very beginning of the infestation. These are the things we are dealing with. So that's giant knotweeds and tree of heaven and black locust. As you can see, most of them are heavily established in Czech Republic. So from that we let's say formulated some requirements for our UAVs. Basically, it has to be as simple as possible because we need to do many flights per day. It's like six flights, and each flight needs to be 80, 100 hectares or something like that. So from that, we see that we need a fixed wing platform. We have used quite a few platforms that we have built ourselves based on like commercial model airplanes. All of them were fitted by open source autopilots. And now we have developed, let's say, optimized platform. We believe that it's got better performance, but it's also simpler, smaller, and you don't need to assemble anything because most of our problems were with you know, connecting cables and stuff like that. So, and we also like to build airplanes. So we have measured the platforms we had. We have reverse engineered them. We have done some simulations to see whether we can improve on them. We have also approached designers to make them nice, but turned out that you know, it's just useless, the designs. So we had to go to the drawing board ourselves and design it. And there's been quite a lot of prototyping. These are actual flying prototypes that we have tested. We have also done some measurements in wind tunnel of the propulsion and materials and stuff like that. And our technicians have had fun building the prototype. So this is the result. Actually, I've got like a physical model with me, so you can have a look and yeah, sense it. Yeah, and during the project, we have also used manned aircraft for the missions where you would be beyond visual line of sight with UAVs, which is obviously forbidden, at least in Czech Republic. This is the general workflow of what we do. We've got quite a lot of airspaces in Czech Republic, so the selection of test sites is heavily influenced by that. So once we select the test site, then we go and do some ground research. For that we use a spectrometer, I would say standard tools. For the UAV, again we use open source software, Mission Planner. By the way, one of the speakers in the morning was concerned with terrain following, so Mission Planner has got this feature integrated for 2 years or something, so that might be of interest to some of you. Yeah, so nothing special. For sensors, we have switched from small consumer cameras. We also have at each point we've got 2 cameras. One is converted to near infrared, and the first one is like a standard visual. So we evolved to have this configuration. It's quite heavy though, but it's got best results because apart from you know, bigger sensor and stuff like that, with the fixed lens, you don't run into problems when landing on a dirty side, because with retractable lens, that's basically killed camera. Okay, the spectral response of our cameras, we've measured that. For example, compared to QuickBird satellite, it's not. I mean, obviously there are some differences and shifts, but it's not too bad. If you compare to World View 2 or something, they've got more bands. So, okay, structure from motion, standard workflow, everything is automated with Python scripts in Photoscan. So I've got a lot of issues and slides about this, but I hope that we'll be able to talk about those tomorrow within the workgroup 1. Okay, and then the most. That's the basics of the project. That's the classification. Unfortunately, I'm not an expert on that, so I would like to ask you to speak to Josef about that. So we use both pixel-based and object-based classification. This is just an example of one of the species and the classification. So I think the main lesson learned from our project is that. It's really for the invasive species. It's really crucial to get the imagery at the correct time, at correct phenophase, because as you can see during the summer, for example, over here, it's not too distinct, but in the autumn you've got much better classification results, and therefore the UAVs are brilliant because they are very flexible in timing of the aerial campaign. So they also have like a better resolution, spatial resolution, but that's kind of outweighed by worse spectral resolution. So we found that for our species that's not a big advantage towards UAVs. Okay, yeah. What do you want to do next? We want to go fully open source also on the processing side, and we also want to implement RTK because at this point we are using post-processing kinematics, so we want to see whether there's any advantage. If you want to see some more information about our project, I would like to invite you to our website. Thanks to our supporters, and that's it.
Any question from the audience, from the back?
Yeah, thanks. It was very awesome presentation, and I want to ask, like, how do you trigger like the parachute by the radio controller, or is it automatically triggered in case of a failure?
There are several options, like either you trigger it by your RC control, or you've got like separate radio link to to have like a parallel radio links in case of your RC transmitter is going to hell. Yeah. And you can also have, some of the DJI products do have like an internal routine to say, okay, there's a problem, so we can sense that as well. Yeah. We've got like DJI integration. Yeah, and basically there's also a dedicated unit for cutting off the engines for multi-rotors and stuff like that. It's got let's say whole ecosystem around it. So
it's good to protect expensive equipment.
Yeah, that's.
And then another, just have you heard of MICMAC for open source photogrammetry?
Yeah. Actually, I would like to go to their summer school.
There is a representative here from Spain, so he is quite in contact. So you should definitely have a talk to him.
Okay, cool. Thanks.
One question from the first row.
Thank you. I really like that project with those invasive species to recognize them. I wonder if you can say something about the classification accuracy. I don't know if the project is in that phase already, but I just wonder, is it
70%, 80, 90? Is it good enough? How does it work? Can you say something more?
Yeah, that's probably a question for Josef, but I think the accuracy is not too bad. That's my impression. But again, I'm an aerospace engineer, so for classification, Josef would be the point of contact. Yeah. I mean, we've published some papers on that with the results and classification accuracy, so that's probably a good point to cut. But yeah, Josef will be able to answer. Sorry.
I have seen a quite big overlap between the spectral response of the green band with the blue and the red ones. There's an overlap in the spectral response of the green band with the other.
Yeah, I think that's the problem of let's say non-scientific sensors. I mean, all the consumer or classical camera cameras do have this problem. So that's a thing we have to deal with if we want to use cheap equipment. Yeah,
Perhaps it's a question for Joseph as well. I don't know. But you're flying big areas in one go then, I mean.
Yeah, like 80 hectares, something like that. Yeah.
What about weather conditions? Popcorn clouds or whatever.
Yeah.
Does that affect the accuracy of your...
That's one of those slides that I had to delete and leave for tomorrow because that's obviously one of the biggest problems, like the non-homogeneous illumination of the area.
And it's a huge effect you have there, or?
Well, it's what I think. I mean, it's not very pleasing to the eye on the outer mosaic, but for what I think is our conclusion that it's not that much affecting the classification. The e-cognition can somehow deal with that. but again, Josef would be the more.
So thanks, Peter, for your speech.
Thanks.
And this was the last question of this session. We are going to conclude now. And do we have some discussion, or we can see after lunch? Okay.
No, we have received a message from. Okay, we have received a message from Professor McCabe from Tufts University, and he asking me to give his regards to all the audience, but essentially he asking me to inform that he received a project that has been funded recently and is willing to support PhD students if there are in this room or eventually in your laboratory for scholarships in KAUST and postdoc opportunities as well. So there are these opportunities that are focused specifically on the use of UAS for precision agriculture. So this is one of the opportunities that always may come from this interaction at the international level. So it's a nice option, and it's nice to know. Now I think if we have now we can take advantage of this 15 minutes. I don't know how much is left to finalize the morning. I think we had a very good sample of experiences, and also we have around this network, within this network, a good range of equipment and experimental devices. So working groups can probably use this information for tomorrow, and we will get even more in the afternoon. We have prepared a short list of information that may be useful to sort out, to synthesize these informations, and I will circulate this list in the afternoon among all of us, in order to help and to provide a sort of guidelines for working groups. And so that's almost it.
Yes, we have different skills within this working group and also different aims of our research. So we need to find something that is shared between us.
Absolutely. Absolutely. Of course, this is we can design the main frame of the project, but if we want to be effective and if we want to obtain a real collaboration, we should let the working group to design more specifically the experiments. Otherwise, the researcher will not be stimulated in achieve this specific result, because it cannot be the project of somebody else. It has to be a joint collaboration. It has to be designed and thought together in order to be achievable and stimulating for everyone. So this is for sure, and that's why we have to design only the general frame and work with the general frame and leave the details. But I do expect that the working group have the ability to describe much better in details what we want in next year and in next 4 years. Otherwise, it would be complicated to coordinate such a huge network of scientists. So this is a challenge. It's something that, but we have brilliant researchers in this room. So I'm quite confident that with the help of everyone, we can reach excellent results.
So thank you very much for coming. It's lunchtime.
All right.
Okay.
Absolutely. Okay. You told me. Yeah, sure. Come here, and give them the announcement. Yeah, I have been invited to submit a paper to this journal recently. I know that the journal is running. There is an open journal named Drone. It may be something we can use in the near future for sure. We can even plan for special issue. It's something that we can certainly do. Now there is one that you are running. Okay,
yes,
but give the announcement. So in the streaming, they will record the announcement.
Can you hear me? So together with my colleague Ricardo Diaz, we are organizing a special issue in a new open access journal called Drones. And this special issue is on biodiversity monitoring using drones. And the deadline for submission is the 31st of July, so there's still plenty of time. So I hope many of you are willing to contribute to this special issue, but also have a look at this new journal, because I think in general also on other special issues and within this cost action, it will be interesting to see how we can exploit the opportunity of this new journal.
Yeah, nothing else to add, but you can find some.
Yeah,
you can find some flyers outside over the table, and then please have a look and don't hesitate to contribute. It will be much welcome for us. Thank you.
Some instructions. The room will be locked. Then you can leave your stuff. Actually, I'm leaving my stuff. And in order to go to the restaurant, if you get lost, the restaurant is called Trinquet. And we must be here at 3. And you can follow the red tags. For example, Ricardo, raise your hand. Or you can follow Santosa, Cristina is here. Myself will be going to the restaurant. Also Guiomar, you know where it is, right? Okay. See you at 3.